Hi, good morning. This is the demo video for my extra credit for the modern cryptography class. So I'll just start the screen share. So this concept is basically that instead of storing hashes of passwords, which kind of gets tricky when you have parts of the files leaked. You make a larger file and then XOR bits and pieces of that larger file to generate a unique identifier for your password, username, and salt combination. So, of course, you need a big, big string or a big file, which we denote by R in this case, which is basically M 128 bits in this case, uh, M such strings which are randomly generated. There's also another vector called as I that I use, which basically is the mapping that we'll use to map random bits from the hash that's generated from the password to generate a unique number or a reference number for that particular for R, and then you generate T such I's, and then you get the basically you get the corresponding R parts, and then you XOR those strings to give you a unique identifier. It's a really cool idea. So let me start with the implementation. The code is a little messy, so I'm gonna skip on showing you the code. It's a lot of if else statements, but it's interactive. So let me start with it. All right. So there are two modes: test correctness and generate performance table. So we'll see the first mode first. As you can see, there are no .dp file. Oh, okay, they are generated. So let's delete them. Okay. So that's the R, I, and salt.dp. We'll delete those. We want those are used for persistence. So we'll use them for persistence later on. So let's uh, so it'll ask you to basically enter three parameters L, J, and M, where L is the string length that you'll be using. J is a random parameter which can be set to 1, 2, or 3 given in the problem statement. However, it can vary. Like it's not exactly a random parameter. And M is the number of strings you want in the random string set. So let's say 1000 for now in this case. So there are two options. One is like a automatic patch test, which I have not implemented right now. It's basically for disk-based access when you want really like a disk-based output thing, so that you can average out things. There's a unit test. So all right, so what we had done was based on IJM, I generated those files and I saved them over there. Now, and I closed them. Now, because I'm doing unit tests, I'll reopen those files. It's asking me for my username. This is basically the register mode wherein you register the username and the password and the salt. So let's say Darshan and my surname as my password. Good combination. Computing completed, and the record has been added to yes, stored in the user data.dp file, which is basically just a tuple of salt, login name, and the code that the scheme generates. We use this string as an identifier overall. So we see if this particular string is existing in this file, we say, yeah, voila, the user is authenticated. Uh, of course, you have to generate the whole thing again on the other end, like every time you want to log in. So I close those files behind, and then this is another file. So reopening those R and I files and salt files, it will ask me again for my login name, Darshan. Let's say Pandit. Uh, yes, user has been re-authenticated, as you can see. Uh, so let's try a fail case. So let's say Darshan It getting completed. Let's try Darshan Pandit 2. As you can see, user has not been authenticated. So, okay, this one more case that we can try. Let me see. I haven't tried this one. Tends to be files. 3, Darshan, and so I'm resetting the file for now. This being said, let me show you the other thing, which is the generate performance table, which basically is a script that runs, well, I think, yeah, well, that runs 1,000 authentication requests and computes the average time taken to compute each of them. Now that thing will vary later on when you have disk access, but for now it is really fast, and it is, well, there's an analysis report that I have written to explain the working. So I'll just show you this. As you can see, this thing is on. So it tries different parameters of J and basically different parameters for T and M. But since T is a multiple of J and L is pretty much a constant, it is actually J. So the script continues for a while. And oh, those things are because the function, like, it reads things every time. So just ignore that because I need to silence that function. See how I just put it in so that we can see that files are being reread again. All right, that being it for now. I hope you like the tool functionality. Thank you. All right, thank you. Have a good day.